Hey, I'm Pranish. I'm a software engineer, and today I want to show you something I built called Crisis Guard. The idea is simple. It's an AI coordination agent for emergency response. Think floods, fires, building collapses. Coordinators type in what's happening, rescue attempts, resource positions, casualty updates, and the agent remembers all of it permanently and answers questions about it in real time. The interesting part isn't the UI. It's what's underneath. Every message this agent processes is stored in persistent long-term memory using something called hindsight from Vectorize. Let me show you why that matters. Most agents I'd built before this had the same problem. They were smart for one conversation, and then they forgot everything. Session ends, context is gone. So imagine this scenario. A coordinator at 9 a.m. logs that Unit 7 was deployed to Oak Avenue. There's a missing child. Water is rising. They write all of that in. The agent confirms it. Now it's 3 p.m. Shift change. New coordinator comes in, opens a fresh session, and asks, what's the status on Oak Avenue? Without persistent memory, you get nothing. The agent has no idea what Oak Avenue is. That's not a UX problem. In emergency response, that's a life safety problem. That's what I needed to fix. So here's how it works now. I'm going to type an incident update directly into the chat, just like a coordinator would. No separate save button, no manual form. Just type. The moment I hit send, two things happen simultaneously. 1. The backend immediately writes that raw message to hindsight memory. Synchronously, before it even starts thinking about a response. 2. It runs a recall pass to check if there's anything already in memory that's relevant. There isn't yet, so it acknowledges the log. Here's what that looks like in the code. Step 1. In every chat request, retain first. The LLM doesn't get involved until after the user's words are in hindsight. Second update. Still building the memory bank. Third update. Now we have 3 separate pieces of information stored in hindsight across this session. Different phrasing, different facts. Here comes the important part. Dash dash dash. Watch this response. It's going to pull from all 3 of those messages at once. There it is. Unit 7, Unit 12. The missing child's description. Red jacket, approximately 8 years. The shelter fill rate, the hypothermia cases. Everything. In one response. That's not the LLM guessing. Every fact in that response was recalled from hindsight. Let me show you how the recall actually works. So the agent doesn't just run one vector search. It first asks the LLM to break the question into 5 subqueries. Things like, Oak Avenue rescue units deployed. Oak Avenue missing persons unaccounted. Medical resources, hypothermia. Each of those hits hindsight separately. The results go into a Python set, automatic deduplication, and then that entire combined context goes into the LLM prompt. New session. New window. The agent still knows about the missing child, because hindsight memory isn't session scoped. Everything written to the memory bank stays there until you explicitly clear it. The shift change problem I showed you at the start, solved. Here's what actually surprised me building this. The hardest part wasn't the memory integration. The hindsight SDK is genuinely about 10 lines of code. The hard part was the recall strategy. My first version ran a single vector search against what the user typed. It worked maybe 70% of the time. The other 30%, it missed facts that were phrased differently. Switching to LLM-generated subqueries, letting the model decide what angles to search from before it even starts retrieving. That's what pushed it to consistent, complete recall. If you're building agents that need to remember things, try that pattern. Generate your queries first. Retrieve with all of them. Deduplicate. The code is all in ..memory.py and ..llm.py. Link to the repo is in the description.